Hello, today we're going to be talking about functions in R. If you want to be a serious R programmer, you have to get really good at defining your own custom functions. There's lots of reasons for doing this, but some of the main reasons are you don't want to have to repeat the same code over and over. So if you're doing that a lot in your R scripts, you should just write a function to execute that code and call the function each time you want to repeat a snippet of code. The other thing is it can make your work a lot easier to maintain. If you're doing the same thing over and over again and you want to make a change to the way you do that thing, say you're generating plots, for example, you're generating a whole bunch of plots for different data sets, but you're basically doing the same thing each time. You can put that code in a function and call the function each time you make the plot. And then if you want to go back later and change how you make the plots, change the axis labels or something like that, you just have to change the code in one spot, rerun your script, and everything will work. So there's lots of reasons for writing your own functions, and that's what we're going to talk about today. This is the first of two videos. The first one will be kind of the basics of how to write a function and to call it. And looking into different parts of the function. And then at the end, we'll talk about how rules work for ordering when you give multiple arguments to the function. The next video is going to be on the important topic of variable scoping. That's going to be a bit shorter, but I think it deserves its own video because that's a really important topic. Okay, so let's define a function. Something not too interesting. I'm going to call it square. And the way you define a custom function in R is with the function. So there's actually a function in R called function. Its arguments are going to be the arguments that you will supply to your custom function. So here we're just going to have one argument. It's called x. And you can give this any name you want. You can call this y or pop or whatever. But I'm just going to call it x. But it's important that when you write the code for the function, you're going to be referencing this argument. Okay, so after the function is called, you have to give it an expression, which is evaluated. And in R, expressions are separated by opening and closing curly braces. And then inside of the expression, inside of these open and closed curly braces, you define what happens when you evaluate the function. And you can put in comments here as well. So it's good practice to say what the function does. So I'm going to say square the argument and assign to y. So that's going to say y is x squared. And then return the value. Okay, it's a very simple function. Basically, it takes an argument x, it takes the square of it, assigns it to a new variable y, and then it returns it. Okay, so we've just defined a function called square. One thing to note is this is the function definition, and then we assign it to an object. So there's going to be an object called square that we can reference. And so let's run that code. And then I could type square here. So when I type square and run this, I'm not calling the function. Basically, all that happens is it prints out what happens in the function. If I want to call the function, I call it just like any other function, which is already defined in R. I have to give it parentheses or round brackets, and then I give it the argument. So essentially what's going to happen here is when I run this line, it takes this value 4, looks up the definition of the function, so it replaces x with 4, and then just runs the all this code, and then returns the value. Okay. And you can see when I call the function, it actually prints it out. That's basically because this thing is getting evaluated to 4. I can assign this to another R object, so I could say a is square of 4. If I do this, nothing gets printed out, but the result is stored in A. Now up here, we used the function to assign a function to this object square. And one of the cool things about R is functions are just objects like any other object. So you can assign them to other objects. So if I say fun is square, I can then call fun of 4 and get the same answer. Okay. So basically there are 3 parts to a function. There are the formals, which is just a kind of formal way of saying the arguments to the function. So I can say, and I can access the 3 parts of the functions with different functions. So formals of square, this returns something, $x. So question here, what type of object does formals return? Well, we could say class formals. This is actually a function. So formals are just the arguments. Body returns the body of the function. So body square. Body is just the stuff that gets evaluated. So this could be a useful function if you want to just return the code that gets evaluated without all the comments in it. We could look at what type of objects this is. This is this kind of object. I believe this means expression, but let's actually look this up. So we're going into the documentation for body. You give it a function, get or set the body of the function, which is basically all of the function definition, but its formal arguments. Here's how you use it. You put in a function. You can also, this is also a replacement function, so you can replace the body of the function with something else. Value. Body returns the body of the function specified. This is normally a language object, most often a call to curly braces. Okay, this is getting deep into internals of how R works, so we won't get into this at this point. But there is something in R called a language object, and if you want to learn more about that, this is basically like a class of objects in R, and you can click through here and follow these links and learn about it. Okay. The third, and this is important for variable scoping, the third part of a function is its environment. So if we do environment square, this returns environment R global environment. So this is going to be important when we come back in the next video and talk about variable scoping. Basically, just to give you a short definition here, the environment is the universe of objects that are available to the function. Just like other objects, functions can have attributes. So let's just look at this. Attributes square is basically only one attribute. If you want to access it, let's see, can you do this? Yes. You can also use the attr function. And the way that function works is you give the object and then the name of the thing you want to access. And then just like other objects, you can set custom attributes. So if we had a bunch of functions and we wanted to kind of group them by different types of functions, we could give them types. So let's say attr square type, and maybe this is a polynomial. And this will show up here when you when you call the attributes function. Okay, let's take a quick look at our function definition again up here. Here's the code we use to define our square function. Now you don't have to be so verbose when you're defining functions. So there are certain shortcuts you can take. Okay. So first thing is you can omit with one M the return. So if I say square is function x, so I'm redefining the function, and then I'll call it. By default, a function will return whatever is evaluated on the last line. So if I do this, it will just return y. However, one difference is that if I do it this way, it's not printing anything out. Now that's because we're actually making an assignment here, and in general, R doesn't print things out when you're making an assignment. However, the answer is saved. If I do A, let me leave this here for you. A is square 4, and then print A. It did make the assignment. So the function did get evaluated, even though nothing's printed out here. Now you can do this. I recommend always writing return here. But some people write R code like this. Then it's very explicit what's actually getting returned. Now, in this case, doing an assignment to Y was actually unnecessary. So we can actually make this code shorter and just say x squared. So what happens in this definition of the function is you give it the argument x, you square it, and then the function will just return whatever is evaluated on the last line. So we can run this and then call it, and this time it does print something out. You can also, like I said, it can be good to give the return value. So let me put this here and say square is function x. So here I'm showing we didn't actually have to assign it to another variable. We could just directly return it. You can also omit the return. So if the function is this simple, do we really need to say return? Probably not. However, in my own R code, I like to always explicitly use return. For something like this, I might not, but in general, I do. Okay, let's see. So this, let's evaluate this. This prints out the result. So does that. Now, I've been putting the function definition on a separate line. It's good to kind of pick a style that you like to code in and then stick to it. For something like this, I would probably not put it on multiple lines. This is really just a matter of style. If this was my function, I would probably write it like this and just have it on one line. If it's this simple, I might even exclude the return because it's not necessary. So I would probably write it like this. And you can actually simplify it even further. You can, if there's only one line of the expression that's getting evaluated, the body, if the body's only one line, you can just do this without the square bracket. So this will work just as easily. And let me prove that to you. That works. And so does that. So it's hard to give a general recommendation. I guess my general recommendation would be to always explicitly return something. Have a line that says return. If it's really simple function, you don't need that. But the general recommendation would just make it clear exactly what the function is doing and what it's giving back. And if you deviate slightly from that, that's actually fine. Okay. Now we've seen different situations where the function will print something out when you call it. So let's look at some examples here. So if you're evaluating a function and then assigning it to another object, it will never print out the result. So even though the square of 3 got assigned to z, it's there. If I do this, it never gets printed out. Sometimes it will print something out when you call it. So let's look at a couple of examples. We've already seen these, but I want to reiterate. Square function x squared. This will print. However, this won't. And like I've said many times before, if you're curious about something, try something out. This just occurred to me. Will this print something out? No. So nothing gets printed out there. So functionally, these are equivalent. But this is equivalent if you're assigning it to something. But if you're not, it's different in that this definition of the function will print something out when you simply call it and not assign it to something, whereas these two will not. All right, up to now we've been working with a very simple function, but of course the functions in your own work will be more complicated. And one of the complications is that often your function will take multiple arguments. And some of those arguments you want to require the user to provide when they call the function, and some of them you may want to make optional and give default values in the case that they don't provide them. So now we're going to talk about how to do exactly that. So I'm going to make a function. I'm going to call it center1 because we're going to have a few different versions of this. And what this function is going to do is it's going to take in a vector x, and it's going to return some measure of centrality of the numbers in that vector. And by default, I want it to calculate the mean, but I'm giving the function I want it to evaluate as an argument so that the user could specify something different from the mean if they preferred a different measure of centrality. So I'm making that function, that measure of centrality, an argument, but I'm giving it a default value. And I'm going to give another argument called the p. And we're going to use this in the definition of function when we talk about another measure of centrality, which is our quantiles. Okay, so what's this function actually going to do? If the user specifies fun to be mean, we're going to return x0 equal to, well, we're going to evaluate first before we return it, x minus mean x. So what this function is going to do is it's going to calculate some measure of centrality, in this case the mean, subtract it off of the original vector to center the vector. Now, otherwise, we're going to have some other conditions. If fun equals median, then we're going to center using the median. And then the next one's a bit more complicated. We're going to do else if fun equals quantile, we're going to subtract off the pth quantile. Otherwise, we're going to throw an error. And then we'll return the value. Okay, so that's our function. It's going to have various different conditions. If it's mean, it'll subtract out the mean, median, subtract out the median, quantile, and then we'll throw an error if it gives not one of those values. All right, now let's test out our function. To do that, I'm going to define a vector for testing it. I'm going to call this y. I'm going to take the integers 1 through 9 and square them. So that's y. And just to see what's going to happen, let's do mean of y, that's 31.66. And then if I call center 1, I have to specify the vector, the first argument, the vector that we're going to be centering. And then I'm going to say fun equals mean, and then close. Okay, so what's happening here? When I defined the function, I gave x without a default argument, I gave fun with a default argument, and I gave p with a default argument. That means if I try to call center 1 without supplying x, it's going to throw an error. Actually, that's the first thing we should do. So if I do center 1 with no arguments, error. Could not find center 1. That's a different error. I have to define this first. And okay, now let's try again. Error in center 1. Argument x is missing with no default. So it tried to evaluate the function. So it looked at the arguments I supply, which were none. And then what it'll do is to look at each one and see if there's a default argument. For these two there is, but for x there's not. So this is the only one it complains about. So I could say, and this will throw an error even if I specify mean. Let me just show you that. So that's an error. Same error. So I need to, at a minimum, specify the vector. So let me call it like this first. So what's going to happen here is it will assign y to x in the function's environment, and then it will evaluate it all this code. I'm not specifying the fun argument, so it's going to default to mean, and I'm not specifying p, so it's going to default to 0.5. All right, so this took center 1 y, and it used mean. So let's see if this makes sense. So what was mean of y? 31.66. So 1 minus this is this. So that seems about right. So it did what we expected it to do. So when it ran through the function, it saw that fun was mean. That's the default argument. Evaluated this, and then skipped everything else because these were else's. And then it returned x0. So that worked as it should. We could have said center 1 y fun equals mean to be really explicit about which function we're using. This should give the same answer. But technically in this function that's unnecessary because mean is the default value for the fun argument. Okay, let's do median just to see what the median is. It's 25. So if I do center 1 y fun equals median, that does what it should do. So it did 1 minus 25 is minus 24. 81 minus 25 is apparently 56. So that worked as it should. If I do quantile y, probs equals 0.25. Actually, let me do this. So this is equivalent to median. So if I do center 1 y fun equals quantile, this should give the same answer as center y fun equals median, The reason is it's going to pick p equals 0.5 for the default value of p. So when it executes this line, this is going to be 0.25, which is the median. Okay, so let's run that. Yes, that's the same answer. Let's rerun it though with a different quantile. And I need to say what p is, 0.25. So the 0.2 quantile is 9, and 1 minus 9 is minus 8. So that worked as it should. Okay, so that's how you define a function with multiple arguments. Some of them default, some of them required, and some of them optional with default values in the case that they're not required. Excuse me, I mean in the case that they're not provided by the user. All right, so you might look at this function and say this is a bit limiting in the sense that there's only 3 possible measures of centrality. You could think of others. And the code is a little bit cumbersome because you have to kind of run through each possibility and check each one and then evaluate different code for each one. So a workaround for this to make the code a little bit more flexible and also simpler is to not specify the function argument as a string, which just then gets matched to something, but specify the function argument as an actual function. And we can do this in R because functions are objects just like any other object, and so we can pass them into other functions as arguments. Okay, so let's try doing that. If that didn't make sense, we're going to try that. All right, I'm going to call this center2 function. X will still be there. And then we're going to do fun equals mean and p equals 0.5. So far the definition is exactly the same, except instead of putting mean in quotes to indicate a string, which then gets matched in an if statement, we're actually supplying the mean function as the fun argument to our center2 function. And then now our code becomes a lot simpler. X minus fun x and return x0. Okay, so our code's a lot simpler, but we'll see it has one kind of fatal flaw in a second here. So let's call this center2 of our vector y. That gives the same answer as before. Center2 y, and then I specify fun equals median. That should work. And let's try the third option, y fun equals quantile. This gives an error. So let's actually see what happens. I'm going to give you a bit of a preview to something that's coming later in the course. We're getting a warning message. So one cool thing about R is it has this debug mode. So I can put center2 in debug mode. We'll get into this in more detail, but I'm going to call it again. Basically, we get to enter into the function and evaluate each thing. So we can look at, well, what's x? That's x. What's fun? Sorry. Print fun. That's what the quantile fun looks like. And we could look at p, that's 0.5. And then we could start to evaluate each line. So if we evaluate that, it's going to give an error. But if I say fun x, those are the default return value of the quantile function. So quantile x will give the same thing if you don't specify which quantile you want to look at. So what it's trying to do is trying to do x minus that vector, and it doesn't like that. So Let's get out of here and go back. That's why we're getting an error here. And oops, I have to undebug. And I'll just run it again to reproduce the error. Okay, so it didn't like that. The reason is the quantile function requires additional arguments to make it work the way we want it to work. So what we need to do is when we define the function, we have to allow the user to pass in more arguments. And by the way, this won't work either, p equals 0.5, because p isn't anywhere in, so p never gets referenced in the function, so you might as well just remove it from here. Okay, so we need to allow the user to specify additional arguments that will get passed to the function we get in. And we can't really plan for all the different possibilities without making the function really complicated. We would basically get back to this kind of situation, except it would be even more complicated. But R has this really cool device called the ... which kind of makes this actually very easy. So I'm going to define a new function called center3, function x, default for the fun is mean, and then I just put ... here. And so what happens is, I'm saying that this function has two arguments, but really we're going to allow the user to specify additional arguments. And the way those additional arguments are going to get used is they're going to be passed directly into whatever function is here. So if the specific function that they want to use requires additional arguments, the user will specify them, hopefully, and then they will just get directly passed via this ... mechanism into the function that they specified. So let's run through this. Center3y, this will do the, oh, no function. This does the mean, subtracts the mean. Center3y, median still works. Center3y quantile doesn't work as before. However, if we give the arguments that are required for quantile, and I think it's called probs, not p. And let's just verify that. Let's look at the quantile documentation. Okay, default has 3 methods. So quantile x, and then the argument is called prob. So which, probs means which of the probabilities do you want to evaluate the quantile function at. So 0.5 would give the median. So this should give the same answer as the median line. Yes, it does. And then I could specify different probs. Okay. Yeah, so this device is a really convenient way to get around this problem. This is how it works. Basically, whatever the user specified gets passed as named arguments into the function here. One more thing, there is something called do.call, which allows you to call functions when they're specified as a string. So let me just, we're not going to get too deep into this, but let me just show you how this works, because this every once in a while will come in handy. So do.call, I'm going to call the mean function, and what I have to specify are the arguments I'm going to pass to the mean function as a list. So list y. So this returns the mean of our vector y. Do.call quantile list. So quantile requires 2 arguments. You have to say which. Actually, it doesn't require the second one, but we want to provide it. 0.25 gives a 0.25 quantile. So what happens is do.call is going to call the quantile function with its first argument being y and its second argument being probs equals 0.25. All right, so that works. Which means we could rewrite our function like this. If we really wanted to specify the function as a string, and just so we can see what's happening, I'm going to print out the arguments. Okay, so let's call this center for y. Let me run this. Okay, so what's happening here is this is the result of this print statement. So the list x and dot dot dot. So this is a list with only one thing in it because we didn't specify anything else in this call. So the dot 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 is basically null or empty. And then this is the return value. So this is giving the same answers before. Center for y median. This again is just the input value for y, which gets mapped to x in the function. That's the return value. Center for y quantile probs equals 0.25. Okay, now we have x so list x comma dot 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 is a list whose first element is x, second element is named argument probs, and the value is 0.25. Okay, so if you really needed the function to specify the function with a string, you can do it this way, and you can use do.call to call the function. There's also something called, just as a bit of a digression here, match.fun. So when called inside, extract a function specified by name. When called inside functions that take a function as argument, extract the desired function object while avoiding undesired matching objects of other types. So basically you give a fun item to match as a function. Function, symbol, or character string. See details. So you could do match.fun of mean. That is the mean function. And I believe you can descend into here. So mean of 1 to 10 is 5.5. Okay, so this is getting a bit deep into advanced R stuff, but do.call, you can use it to call functions that are given as strings. And then I believe internally that's using match.fun, which is matching strings to actual functions. Now, we covered this briefly in a prior video, but I want to go back over it here just to make this point again about how the arguments that you pass to the function get assigned to the function arguments when they're not named. Okay, so let's look at the documentation for seek. This is a good way to see how to call a function. And we're looking here. So seek has various arguments from a to. I guess we should read this first. Generate regular sequences. Seek was a standard generic with a default method. Seek.int, that we're not worried about that. Seek along, seek len, we haven't seen yet. So we're just using seek right now. This is used to generate sequences. Starting from this value and going to this value. And then you have to specify, well, you don't have to because there's default values, but you can specify the interval along which you'll seek. We'll see some examples of this in just a second. And then optionally, you can instead give length.out, which just gives the length of the desired sequence. So let's just call this a few times just to get a sense of what's going. Seek 0 to 1 by equals 0.1. So this is giving numbers from 0 to 1 by 0.1. You can also say seek 0, 1 length dot out equals, let's say, 5. So that from 0 to 1, and you want the resulting vector to have length 5. Okay. All right. Now that's just how it works. So let's call it a few more times. X is no, I think that's sufficient. So what's going on here is, and let's pull up the documentation for seek again. It's going to, so here's the arguments you gave it. Let's do this one first. You gave it 3 arguments. This one doesn't have a name associated to it. So R has to figure out which one of these to match it to. And the rule it uses is it just goes to the first one that's not specified. So 0 gets mapped to from. Here's the second one. Now it moves. It also doesn't have a name, so R has to figure out which one it gets mapped to. And it just takes the next one that's not matched yet. And then this one is named, so there's no ambiguity about which one to set it to. So it sets by to 0.1. And if you look at the code here, we're not going to, I guess we could dig into the code, but if you look at here, it's referencing to, which we've already said we have something for. It's referencing from, but it's also referencing length.out, which we didn't specify, so its value is null. So this is actually kind of strange. So let's look at the code actually. Seek dot default will have the code. Oof, okay. Wow, there's a lot of code here. I don't think we're going to be able to quickly find where it's, oh, maybe it's here. Else if missing length.out. Oh, if not missing. I don't think we're going to be able to find it. So there's a lot of code here. So somehow it figures out if length.out is not specified, it sets it to null, and then it has to do something slightly different here. Now, if we specify, the more interesting case is this one. Here it maps 0 to from, 1 to 2, and then it sets length.out not to null, but to our specified value 5. And then it looks at this one, and it knows to, it knows from, it knows length.out because we specified it. And then it just calculates the by directly here in the arguments. Okay. Let's look at another example, the plot function. And let's see, we'll do default scatter plot function. So here's a function. You probably used plot in R before. There's lots of things you can customize about plots in R. We're going to do a whole video or two just on that. So there's lots of things you can specify. The only required argument is actually X. And you can read about what all these arguments do. So if we take, let's generate some data. Let's use this. X is this. And we're going to plot X. Actually, let's define Y first. Y is X plus R norm length X, just to give some data, and plot XY. Get rid of this. Comment that. Okay, so that's our data that we're plotting. By the way, it's showing up in this panel here. We can minimize it with this button here. If we do plot x, y, o, what's going to happen? Well, it does that, but we have to look in the documentation to see which argument o gets mapped to. And you just remember the rule. So the first one is x. The second one doesn't have a name. So the fact that it's called y has nothing to do with the fact that it got assigned to the argument y. I could have called it something else. It would still get assigned here because it's the second unnamed argument, and therefore it has to go to the second argument here. The O will just get mapped to the next one, which is the type of plotting symbol. I put type equals O, which connects them. If we click here, puts the circles in, but also connects them by lines. Let's do one more example. Plot X, Y, and I'm going to do them out of order. Let's run this. Not 20. Let's do 1.5. Okay, so I changed the x-axis. And so what's happening here? Same thing happens to these two arguments. No ambiguity here because it's named. And then we'll pull up the documentation again. This one is unnamed. And it just reverts to the first one in the sequence of argument that doesn't already have a value. So even though this came after xlim, it doesn't set this to ylim, which is the next one. It goes back and takes the first one that's not specified. Now, I don't recommend writing the code this way because now the user has to go, if they're not familiar with the ordering of the arguments in the plot function, they have to go into the documentation and figure out what this actually gets mapped to. So what would be better is to say type equals O. Most R programmers are going to be familiar enough with the default plot function to know that the first argument is what gets plotted along the horizontal axis and the second one is the vertical. But all the other ones probably need names because nobody's going to remember the ordering of the rest of the arguments. All right, that's it for this video on defining and calling functions. It's really not that complicated, but some of the things you have to remember are how to give default arguments, what happens when you give arguments out of order, how do they get mapped, when some of them are named and some are unnamed, and then calling functions. The next one we're going to look at a little bit more advanced topic called variable scoping. It's not that complicated, but we really need to understand how this works.